Hey, AP Chemistry. Yep, I took it outside. You're probably watching this in October. Well, it's a beautiful July day and beautiful underneath the shade. Today we're going to take a very quick look at the math component of this unit, which involves molarity, dilutions, and titrations. Molarity is just how concentrated a solution is. We calculate it simply by taking the moles of solute and dividing it by the volume in liters. It's a great conversion tool. If you're looking for moles, just multiply by the volume. If you're looking for volume, flip the molarity over and divide. If you take a look at my example, let's say you have a 5 molar solution, 5 moles per liter. When you flip it over, you always put the number with moles. So 1 liter divided by 5 moles, and you get 5 liters. Just pay attention to your labels. It's a great tool. If you're going to talk about molarity and concentration, we should address dilutions. Simply taking a concentrated solution and adding water. The amount of the solute stays the same. A lot of students think that you're actually changing how much salt or sugar or whatever's in the solution. You're not. You're just adding water and changing the volume. I like to use the M1V1 equation. Your book changes the subscripts. They call it the concentrated molarity and the concentrated volume versus the diluted volume and molarity. It doesn't matter. Quick example, how much 6 molar HCl is required to make 500 milliliters of a 3 molar HCl solution? So plug in your numbers. The 6 molar goes with V because we don't know the volume, and 3 times 500. You do not need to turn everything into liters. It works just fine, but your answer will be in milliliters. So 3 times 500 is 1,500. Divide that by 6 and you get 250 milliliters. Please do your algebra correctly. I've seen kids get this far and do the algebra incorrectly. If you were actually going to make this solution, you would take the 250 milliliters of the 6 molar HCl and add 250 milliliters of distilled water. Combined, you get the 500 milliliter solution. We can't discuss concentration and acids and bases without discussing titration, and we'll actually do a couple of labs using titration. Titration can be used with acids and bases, redox reactions, and precipitation reactions. Basically, you're using it to find the concentration of an unknown substance. Take a look at the basic diagram setup. In the flask or beaker, you have the unknown solution, but you do know how much you have. In the burette above, you have, if the acid is in the flask, you would have the base in the burette. You know the concentration, and you're going to know how much it takes to titrate it. So you need to find the volume. There's 2 different ways to know when you've reached the end of your titration. One is called endpoint, and that's just when the color changes, you use an indicator. The other is to look at the equivalence point. Now that comes from the graph, and that's where the concentration of hydrogen ions equals the concentration of hydroxide ions. If you take a look at the graph, you get that kind of straight vertical piece of the graph. You find the midpoint, you go over and look at the pH. That is your equivalence point, and that's how you use the graph to find your pH and your volume. If your acid and your base are in a 1-to-1 ratio, like sodium hydroxide and HCl would be in a 1-to-1 ratio, you can use M1V1. But when they're not in a 1-to-1, you need to do stoichiometry. This diagram is from your textbook, and it shows the stoichiometry involved in finding the concentration of an unknown substance. When they are not in a 1-to-1 concentration, I really recommend using this. You can use the M1V1 equation, but chances are you're going to do it wrong. Take your volume of the standard solution and turn that into moles. In other words, how many moles of the base, for example, did it take? Then do a mole ratio using your equation and go back to concentration by dividing it by the volume. We will practice this in the class. So hopefully at the end of this quick little video, you're caught up again on molarity, dilutions, and titrations.